Hi, I'm James Urquhart. Welcome to my talk today about async API and the worldwide flow. And certainly hope everyone is doing well wherever you are in the world and whatever time it is. Really, the topic of this conversation is the idea of driving business, speeding up the flow of business through event-driven integration and basically integrating the communication of changes of things of activity and changes of state between organizations, and ultimately as organizations connect to each other, kind of creating a giant set of those connections, which I call the worldwide flow. I'll start by defining the term flow a little bit because it's a heavily overloaded term, and we all know that you can find that word used in tech in a million different places. In this case, I want to be very specific with the definition. I'm talking about flow in terms of an event-driven integration across organization boundaries, meaning either between and from one business division to another business division within a company, but even more excitedly to me is from a company to another company, or a company to a government institution, or any of those sort of cross different organizational entity boundaries that might happen. And then doing this through standard interfaces and protocols, which we'll talk a lot more about here in a bit. But using standards so that everybody, it's as simple as possible to make these integrations happen. Now, the term WWF has a little bit of a history, at least in the United States, right? There's a big battle between the World Wrestling Federation, or the Wrestling Entertainment Organization, and the World Wildlife Fund, which was this wonderful, peaceful protector of animals across the planet. So unfortunately, the letters WWF have a little bit of an overloaded connotation. But in reality, what I'm talking about is a concept that I go through in great depth in my book, Flow Architectures, The Future of Streaming and Event-Driven Integration. And really is encapsulated by this sort of tagline, right? As HTTP linked the world's information and created the world's web, flow standards will link the world's activity and create the worldwide flow. And I really think it has the chance of having the same or bigger impact that HTTP had on the way that we link what's happening in the world, who we are, the ways that we interact with each other in the world. Not to oversell it, but really, if you lower the cost of this integration greatly, you're going to create this explosion of new integrations that happen, and who knows where that's going to take us. And another way to picture this is really just in terms of EDA. So, here's Fran presented this earlier in the conference as sort of a very simplistic picture of an EDA. And I want you to kind of take a look at this and, think about this. Okay, instead of being within an application system and a very simple set of software services, what if it's companies? So imagine that the European Weather Center for Weather sends their predictions to DHL, a transportation company, and that transportation company in turn sends signals to suppliers, to manufacturers, to shippers, to say, hey, these are when trucks are going to be available. These are the capacity elements that are going to be available. This is what weather effects will have in terms of travel times. And then also at the same time can send signals to the consumers about, hey, your package may be delayed a little bit because of this weather event, or hey, we had really easy travel conditions, so we predicted this will be at your front door, in this 10-minute window period. There's a lot of other activities like this that you could imagine. Things in finance where people are exchanging information about transactions that have occurred, or movements in stock price and other things like that. Healthcare, there's the obvious condition, sort of tracking patient conditions and being able to set off alarms or react quickly or automate corrections to things when health deteriorates. But I think just as interesting are the signals that can be sent between healthcare organizations about available beds, about supplies needed, about the current state of and changing state of their emergency room capacity, and their ability to handle new ambulance loads, right? So most of the time that may be very mundane. There's not much to do. It is what it is. But if there's a crisis, then that data may be very, very good at signaling that there's a crisis underway, and at the same time also enabling these organizations to coordinate with each other better and faster. I started this exploration by sort of asking the question, okay, if you're going to do flow, if you're going to do event-driven integration across organization boundaries, what are the pieces and parts that you need? And really a large chunk of what needs to be there is the stuff that's sort of more to the right? The sources and sinks, sinks database storage is readily available from any cloud provider in several forms as a managed service. It's just a utility pretty much at this point. Even the ability to process data or the queues that we use to sort of buffer event data and broker event data. Those things are sort of very, open source projects. Apache alone is, probably got 15 or 20 projects that kind of fit into the queue and processor space in some way. There's a lot of really, really powerful things out there that are kind of readily available. So the pieces are set up on the board for Flow to be out there and be successful. What's missing, though, is the stuff that's to the left. What's missing is the stuff that's related to the standard interfaces and protocols that are needed to make this integration as simple as possible. And so this is what I explored in the book as sort of what would it take, what are the elements that have to be there, and what is the landscape today, and how will that potentially encourage the movement of these things. And so get a little bit more kind of definition of what I mean by interface and protocols. So protocols, we're all very kind of aware of sort of the wire level protocols, TCP/IP, and then on top of that, things like MQTT and AMCQ and all these different other things that are really critical that we use all the time. But packaging the event data itself is extremely important. On top of it, the thing that's carried by those protocols on the wire is very important. So metadata is just setting the context of the event. Not only where did the event come from, is it connected to any other events, but also things like, what does it take to be able to process the event? What's the format of the payload? What's the size of the payload? And what encryption is being used, right? There's all kinds of things that could be represented in metadata. And then the payload itself, which is, whatever the data is that we're communicating, this state change of an individual value, the new state of a complex set of data structure, whatever it may be that we're communicating. And then on the interface side, there's really two interfaces that I was able to kind of narrow things down to. So one is discovery, which seems like it's very kind of extra at first, but it turns out to be really, really important. In order to understand not only that there exists a stream that has a certain type of information that you want to consume, but also what does it take to be able to consume that stream? How do you filter for information, or how much volume can you expect to receive? What compute capacity would you calculate off of that? Excuse me. And then there's the subscription API, which is sort of what everybody, thinks about right away, the subscription interface, right? So, which is really important to allow a publisher to say, hey, I'm making this data available, and allows a consumer to say, hey, I want to connect to that topic, maybe with this filter, and I want to be able to consume that data. And by the way, to authenticate that they are who they are and that they're allowed access and so on. And some examples of that then, and sort of really narrowing down on kind of how close we're getting here. So we've got standard wire protocols all over the place. MQTT, MQP I talked about. WebSockets is really big. And increasingly I see that out there, especially for point-to-point connections when you're not going through a broker. There's also the metadata, and I really think, and I'll make the argument through the rest of this talk, that Cloud Events really has the inside track here. It's just by far not only the best expression of the metadata required, I think by far, but also the most used and utilized by vendors and cloud providers and so on. So it's really got kind of it's beginning to be adopted very quickly. Then I think for the payload, my belief is that ultimately the standards in payload are going to not be sort of general standards, but are going to be specific to industry. So, it may be, embedding fixed financial transaction information into a payload. It may be, healthcare related. It could be custom protocols that get built by, say, a small group of vendors that are working together in a special way to accomplish something. And it may be options that we can't even imagine today, right? There may be government-defined payload standards for certain types of transactions or certain types of information exchange. We don't know, but the payload has to be flexible enough for all these different kinds of things to be represented as they need to be represented so they can be consumed. And then the interface side, I really think AsyncAPI, all the evidence I have points to AsyncAPI having the inside track. And I say that, and I'll explain more in detail why in a second, but really the big things here is AsyncAPI kind of combined with a number of things is something that allows you to get to the AsyncAPI documents, to discover the AsyncAPI documents. It's really like a self-contained set of information that's consistently communicated, right? So you can get a description of the API fairly easily. Now, how do you find those AsyncAPI files? Well, that might be somebody sets up a registry service or something like that. I think personally the most likely thing is that people will kind of make them available on just developer websites somewhere, right? And people will Google for them. Google will be the primary search mechanism for the discovery. AsyncAPI will be the representation of the API that is either machine or human consumable out of the result of that. It's all, again, speculative, but I think there's a solid evidence that at the very least AsyncAPI docs have a very likely chance of being a part of that. And then subscription, AsyncAPI, again, I see that way more than anything else that's out there. There is other options, simpler, more specifically defined for PubSub, for instance. So the PubSub API from Salesforce is the example I give here. There's some, the EventBridge API, there's the Google PubSub API. There's other things, Kafka API, that could potentially kind of win out for the subscription API, but I really think it needs something like AsyncAPI that's more general, more and I'll adaptable, extensible. I'll talk about this stuff a little bit more here in a second. Now, one of the things you can do with these Worley maps that I've been showing you here is you can begin to think about, hey, if everything's sort of being custom built or it's product based or whatever now, what happens if, as the industry begins to mature that technology to the point where those things become basic commodities? And so it's especially interesting that all that stuff that I had circled on the right before is all needs to evolve. This is the opportunity. This is why there's a door open here for a standard to appear for the interfaces. So AsyncAPI plays the role of interface really well. It's a way of describing topics and connections. It's exactly what you need, right? Here's some information about it. Here's the the servers you can go connect to. Here are the channels that are available on those servers. Here are the components that are described, the elements that are described as part of these events. It's solid. I mean, this is the 2.0 spec. I know there's some changes coming with the 3.0 spec, but the basic pattern here and what we're learning as we implement these patterns leads to a really good way of sort of a basic description of what the API is for the interface to a flow service of some sort. I also like the fact that so far it's fairly consistent, right? We've got some major releases happening at a fairly good clip now. Hopefully with 3.0, third time's a charm, we begin to slow down kind of the major changes to the way things work. But it is something that has a solid community around it, has vendors that depend on it. That consistency is almost going to become guaranteed by just the momentum that's created by its usage, and the fact that breaking changes will be harder and harder as we go forward. It's also very adaptable, which is incredibly important, because who knows what event-driven integration is going to look like 20 years from now. It needs to be able to be extendable. It needs to be able to, there needs to be a process by which the standards can change if they need to change. And that will help it live longer and be important and survive as a standard for a long time. It's also discovery friendly, which I talked a lot about in a little bit earlier, but that's just a super really cool thing to add into it. It's also, and this is maybe the most important reason why AsyncAPI is inside track, is it's getting adopted. It has a community that's consuming it. It has the usage of these different vendors, these different implementers of AsyncAPI that are happening. And as that grows, as the number of organizations that are using AsyncAPI grow, and as they begin to offer those connections to other organizations and use it as a flow standard, that's how something becomes a standard in the modern era. You don't just declare it as a standard. You have to go get people to adopt it and validate it. Running code wins, right? And so you can say some similar things about cloud events as well, by the way, and it's important to kind of note them, right? So first of all, it's a way of describing perfectly, near perfectly well, the metadata of an event. It's really well thought out. There's been a huge amount of time put into it, a huge amount of kind of experimenting with different ways of doing things. And ultimately, it boils down to a very few required elements. These 3 elements on the left are the only required elements in this list. And then a whole bunch of stuff that can be added or extended in the definition of the metadata for that object, which all this makes it consistent. There's a community and a standard document and a way of updating the standard that allows the community to kind of move along together as a group. And it's extensible and adaptable to what's happening. But the big thing with cloud events is really nice. It also adapts to different usages of events. So you may have some systems that have a Kafka-like story where they need a connection of events that are related to each other, and that dependency is understood so that you can track through that as you step through the topics, and sort of rewind and play through it again. But others may just be sending a state change that's captured by a digital twin model that just essentially forgets when it captures that state change, records it, and says, okay, next event, next event, next event. And that connection between events is much less important to the way that processing happens. And it works really well with Lambda events, and it works really well with, there's this huge list of stuff, of types of processing. In fact, in the book, I have a really good diagram that kind of explains what are the different types of processors you use for different ways you want to consume events. And Cloud Events adapts to all of it. And that title is wrong. That should say Cloud Events. Also, by the way, why Cloud Events? It's being adopted, right? It's their implementation out there. This list is just a very small partial piece of what they have on their website, indicating people who've actually built integrations that use cloud events as the metadata packaging for the events that they either transmit or consume. There's a great list of vendors that are involved in the working group that is maintaining the standard. There's a great list of vendors who have come around and integrated some form of adapter or core functionality of their system that is cloud event aware and cloud event friendly. And you have things like Knative that make building platform elements that can consume those events much, much, much easier. It just eliminates a huge amount of the toil required to be able to capture and interpret those the metadata in order to present the payloads correctly. And I think really then you have to kind of look at what happens when you bring those two together. And this is what kind of excites me. Again, we want to go back to this idea that we want to make it super easy for everybody to connect into this web of streams that's available out there. And so, so bringing cloud events and AsyncAPI together kind of gives you, I think, that proper collection of the right extensibility, the right separation of concerns to be able to enable flow to happen. And there are a few areas where there's still some some overlap. Certainly protocol bindings like MQTT and AMQP protocol bindings, but both both sets of standards generate their bindings. There has to be some reconciliation around that. But for the most part, really well set up to happen. And you can hear our discussion. This is Fran from the AsyncAPI side, Clemens Vasters representing from Microsoft, representing the Cloud Events group, and then myself sort of representing the Flow architecture author, and kind of talking about these ways that these things can work together to create that flow future. What's the opportunity then here? And I think this is the most exciting part of this whole thing, is there's a ton of opportunity. So first of all, AsyncAPI becoming part of CNCF, what a just a wonderful collection of technologies to bring together. And I think it really simplifies the ability for these working groups to get together and have these conversations about how can we facilitate a solution to these forms of integration as they become more aware and more obvious. And so, and I think, I've talked to the guys at NATS that work on NATS a few times about this. They're very, very open. As the flow standard appears, they want to make sure that NATS supports it very well. And I know that the API community could really use not only what AsyncAPI is doing today for all forms of event exchanges, but as we get into to doing these flow exchanges, I think it's going to be incredibly important to get to get the API community what they want in a way that they can consume it easily today. So again, really well set up. Some usability things that are missing, right? We don't have that way of just sort of saying, hey, here's a topic, I want to connect to it, right? There's no libraries that really bring AsyncAPI and Cloud Events together yet into a just super easily consumable piece. We do, some code generation stuff, that's great. And I think that work is really important. But I think there's no sort of like, hey, it's just built into a programming language, or it's just built into an operating system or a framework or whatever. So we'll see. I think some of that stuff started to happen as sort of the flywheel of demand and need sort of starts to spin out. Security authentication, I think, is still not, doesn't have quite the spotlight it needs. I think it's probably the most important problem that really needs to be solved well. And I know there's stuff about that in AsyncAPI. I think, just real clarity in terms of, especially if there's other standards that are being consumed, and sort of highlighting that the secure way of connecting in a standard way is really important to building trust in a commercial setting and in a government setting. And then adoption. We just need to make it as easy as possible for people to adopt Flow. And initially that's going to be a little bit rough because we don't know what all the pieces are yet. We haven't got it all working together. But I think in 5 years, the goal would be really good to say, look, we want to make it super simple. If somebody, wants to write an application that they want to connect to a Flow compatible stream, that it's super simple to do it. And here's all the code ready to go to do it. Or here's the library that does it for you, whatever that may be. So adoptability, onboarding is really important. And then some future opportunity here that I think is super, super exciting, right? So, maybe longer term than some of the others here, but monetization is one that I look at, and it's not just how can I charge to let somebody connect to my stream, but are there ways to charge for people to share that data with others, or to charge people to take, to license a piece of the data that's in there for use in other purposes entirely, or to pass it on to, whatever it may be, process it in certain ways. There's some exciting possibilities there. I think observability is a really hard one. Not only how can I see the things I control, but how can I see where my data is flowing outside of my control? And, lots of questions about, what's privacy, what isn't, what's trade secret, what isn't, that have to be answered there. But ultimately, I think there's a great opportunity here for being able to visualize how your activity is triggering activity elsewhere, or are what you're waiting for, whether you're getting accurate information from a source, and you're getting all the information you should be from a source. Where did all this data come from, right? And then that brings me to provenance. And I really think the next billion-dollar company that comes out of EDA is going to be somebody who really kind of solves core provenance. Not only who is the origin and can I validate the origin of the data, but is the data as I receive it still as it was intended to be sent? Has it been altered in some way? Has it been added to in some way that's unexpected? And also, as this data moves through kind of multiple, it gets maybe reposted in a different topic for some by a different party, whatever it may be. That kind of the core origin of each of the data elements is in some way validatable as having come from the source as a part of that event context. So provenance, I mean, everybody I talk to in the space is that's one of the biggest problems is how do I solve the problem of making sure my data provenance is understood and that I am not working off of some mocked data or malicious data of some sort. And with that, I think I'll wrap up and just say thank you very much. Again, opportunity is huge here. AsyncAPI very much has an inside track. It's a really well-designed standard for the purpose. I hope the 3.0 stuff takes it even further. I'm going to be very excited to kind of watch what happens with that. And then, but ultimately, where we want to get is, again, that ability, if we can make it super cheap for people to consume events from other organizations, there's a whole bunch of things that I think, I certainly couldn't imagine that can come out of that. Some bad maybe, but mostly good, and mostly really fundamentally changing the speed at which business happens on the internet. So thank you very much.